So we're going to start talking about Chapter 5, and now we're continuing on with some of the stuff that we already worked on for Chapter 4. So let's go through that right now just to make sure that makes sense, just to review the vocabulary. So let's start with this. Slope. So first of all, slope, all it is rise over run, the change in y over the change in x. So if we have these 2 points, then all we do is 0 minus -1 over, then we got 4 minus 2. When we do that, minus -1 is just 1. 4 minus 2 is going to be 2. So the slope is going to be 1/2. Slope for this line is going to be, 5 minus -3 again. Make sure that it's always going to be the difference between the points, and make sure that you do it with the x and the y. Sometimes students make a mistake and they try and they combine them the wrong way, or try and find the difference the wrong way, and confuse x with y with what they subtracted. Y goes with y, x goes with x when you're doing slope. So this is going to be 8, and then this is going to be 2, so it's just going to be a slope of 4. Next problem. So hopefully, again, that should seem pretty familiar. A landscape architect charges $75 per consulting fee and $30 per hour. Write an equation that shows the cost, C, as a function of T, time, and hours. Okay, so we got T. That's going to be our variable. So they charge a consulting fee. That means no matter what, they're going to charge us $75. Even if they do no work, they come out, they view the stuff at your house, they say, oh, it's worth my time if I charge $75. So $75 is going to be a set cost no matter what. And then it says, and $30 per hour. Okay, well, that's how we relate to this T. And you can get that hint because it's per hour. You got that per hour thing. And we got this time in hours. So it's going to be 30T. And the cost, C, is just going to be equal to these two things added together. So it's going to be 30T plus 75. So that's how we do that problem, just setting up an equation. Next, I want to do a brief review of these questions of the day. It says here, in the formula for slope, which values represent the rise? Well, if we have that, the rise is always going to be on top. Which values represent the run? Run is always going to be on the bottom. Now, remember, the rise is the change in y. This is going to be the change in x. So that is just, it's generally one of the ways it's written is y2, that's the second y point, minus y1 over x2 minus x1. So that's basically the formula for slope. What is a y-intercept? That's where the actual graph that you're graphing, a linear graph, where the y, the graph actually crosses the y-axis. So it's actually where x is equal to 0 for the graph. It's always going to be where it crosses the y-axis and where x is equal to 0. So if you visualize this as something like this, it's always going to be somewhere on this line here. That is going to be the y-intercept. If you look for a coordinate point, how can you tell if it's a y-intercept? Well, the easiest way is back up to here. If x is equal to 0, if you have 0, 5, then the actual point is, the y-intercept is going to be 5. What is the slope-intercept form of an equation of a line? Y equals mx plus b. Now, the y and the x you're probably familiar with, you should be familiar with, they're just the points on the graph. M is going to be the slope value, and b is the y-intercept. So, moving on here, what value represents the slope? That's going to be m. What value represents the y-intercept? That's going to be b. what do the x and y values represent? They represent anything that matches up. If you have plug in a value, most of the time you're going to plug in a value for x, and then you're just going to come up with a value of y based on the equation. So that's how it works. You plug in a value for x, you multiply it by the slope, then you add the y-intercept, and you end up with your value of y. And those represent solutions of the graph. Write an equation of the line with a slope of 1/2 and a y-intercept of -7. Okay, if we were to do this, if we're doing we should just automatically use a y-intercept form. So y equals mx plus b. Okay, what's slope going to be? 1/2 x. What's the y-intercept going to be? Plus b. In this case here, we can change it to -7, or you could do plus -7 if you wanted to. That's how you do it. Again, what you have here is you have the slope value here. That's the first thing, and then the y-intercept value. If you have those two things, you should be able to graph any linear equation. And for this point here, for this problem here, it says here, write an equation of the line shown. And it says 0, 2, and 2, -1. Okay, first off, you need to figure out, well, you got y is equal to something times x plus something. If we look at that graph quickly, we can already figure out what this something is. That something is going to be 2. So now we just have to figure out the slope, because we've got the something x plus 2. So let's figure out that point. If we wanted to, we could do this a couple of different ways. But one of the ways, the most easy way of doing it, I think, is to just go ahead and take this and count off. Okay, first of all, we know it's going to be a negative slope because it's going down. It's going down. It's a negative slope. So all we should do is we should just count off. We should find points that match up and then count off. We got points right here. Here's 1. And then 0, 2 is 1 as well. So all we do is we count. Well, we're going down 1, 2, 3. So 3 is going to be, remember it's negative. 3 is going to be the rise, and then we're going over 1, 2. So, and then we're going over 2. One way of thinking about this also that's sometimes helpful is actually to draw something like this. To draw a triangle and then count it that way. And you'll see that it's -3x. So our line is going to be y is equal to -3 half x plus 2. That is going to be your slope-intercept form of that line. And again, here's another perfect example of this. So right now, look at it quickly. What's going to be the y-intercept? It's going to be -2. Got half the equation solved. What's the slope going to be? You don't even probably need to figure this out because you've got the slope right there. It counts it up. It's going to be 5 over 3x minus 2. And that's how this works. And you've got a positive slope. That's one thing to also check just to make sure. So moving on here. When you write, it says write an equation for the linear function with the values f of 0 is equal to 3 and f of -4 is equal to 11. Okay, first things first. You're going to look at this. You can rewrite these as points. So this is going to be the point 0, 3. I know people feel more comfortable with when they got the points written out that way. Second, calculate the slope. What's the slope going to be? It's going to be 11, change in y, minus 3, because again, this compared to that, and then change in x minus, so we're going to go ahead and change that just so that, make sure that that's clear. Make sure that that makes perfect sense. So we're comparing this and this. And when we figure it out, we have 8 over negative 4. So the answer for the slope is going to be negative 2. Okay, that's the first part. Now, you've got the y-intercept. The y-intercept is right here. So that there should be just logical that that's going to be 3. You've got your slope, which is negative 2. So remember, when we use function notation, it's pretty much the same as using y. Okay, so you rewrite it that way. Our slope is here. Our y-intercept is here. And so that's how we figure out those points there. So let's try a couple more quickly. Write an equation for the linear function with the given values. Okay, again, rewrite these. 0, 7 is going to be 1 point. And then 12, 15 is going to be another point. Slope is going to be 15 minus 7 over 12 minus 0. So that's going to be 8 over 12. So if we were to simplify that, as we should, it's going to be 2 over 3. That's going to be equal to m, the slope. So now we just look and we see, hey, we got our, oh my, and we got our lovely y-intercept right there. So it's just going to be y is equal to, well, I prefer to write it this way to start with, and then I'll change it into the function form. Plus 7. Again, I got the 7 from right there, and I got the slope from here. And if I were to rewrite this out function form, f of x is equal to 2/3 x plus 7. Okay, so for these things here, same sort of idea, 0, 21, 4, 13. So what's going to be the slope? It's going to be, well, 13 minus 21 over 4 minus 0. 8, but negative 8 over 4. So that's going to be negative 2. So that's going to be our slope. And then we already have our y-intercept there. So our function, as I said, I like to do it this way just because it makes me feel more comfortable. Negative 2x plus 21. So the function of x is equal to negative 2x plus 21. Last problem down here. Same sort of idea here. 3, negative 12, and 0, 6. Okay, 6 minus negative 12 over 0 minus 3. That's going to give us 6 minus negative 12, that's 18 over negative 3. That's going to give us a slope of negative 6. And then we have our y-intercept right here. So it's going to be y is equal to the slope, which is negative 6x plus 6. And so if we were to write that in function form, f of x is equal to negative 6x plus 6. So as an example, word problem here, a dance academy charges $20 to use the facility and $25 per hour for instruction. Write an equation that gives the total cost to learn dance at the academy as a function of hours of instruction. Okay, so first off, you're paying this $20 here even if you don't dance. That's a set cost, no matter what. That's for rental. And then here is how much you're charging per hour. So we're just going to say let h, remember to define your variables, let h equal number of hours of dance instruction. So now we're trying to relate this. The cost and C is the cost. So C is going to be equal to, well, first off, it's going to be $20 no matter what. But then you've got to multiply $25 per hour, because those two things are related. Now, if we were to plug these two things back in for 2 hours, what's it going to be? C is going to be equal to 25 times 2 plus 20. So that's going to end up giving us 50 plus 20, which is going to be equal to 70. So that's going to be our total cost for 2 hours. And so this whole idea of how you do this y-intercept form, how do you graph an equation of a line with slope-intercept form? An equation is just the y equals mx plus b thing, and that y-intercept is b. When you are given 2 points on a graph, one of which gives the y-intercept, you can find the slope, and then you can plunk down the y-intercept and then substitute those values in. And then you can write a function in slope-intercept form with the given values, particularly if you have f of 0 right there, because that's going to be your what would be the equivalent of y-intercept. To write the equation in slope-intercept form, substitute the slope in m and the y-intercept for b in the equation y equals mx plus b. And so that's basically how this all works.